Welcome back to another episode of Georgia Forages, the digital series. My name is Dr. Lisa Baxter, and I'm your University of Georgia State Forage Extension Specialist. Today we are focusing on understanding a forage test. Let's start by reviewing some of the numbers that you may see on a forage test report. We'll look at all of these numbers on a dry matter basis because it removes the variation in the hay moisture and allows us to compare multiple samples. NDF, or neutral detergent fiber, is the total fiber in the hay, and so as NDF increases, intake will decrease. ADF, or acid detergent fiber, is the least digestible fiber in the hay, and so as ADF is increasing, our energy content will decrease. Lignin is the indigestible part of the cell wall, and so we want this number to be as low as possible. Crude protein is just an estimation based on nitrogen content in the hay. It doesn't tell us if it's good, usable protein or toxic nitrates, and so we need to beware of samples with a very high protein level. There are several ways to look at digestibility, but in vitro true dry matter digestibility, usually at that 48-hour mark, is the most common one we'll look at. This represents how much forage the animal could digest in a 48-hour period. Now we can use these different parameters to calculate some of the values that we often look first for on a forage test. One of those is TDN, or total digestible nutrient, which is a calculated measure of the energy value of the forage. There's also DMI, or dry matter intake, which is a prediction of the dry matter consumed by the animal. And finally, we have RFQ, which is an index that allows us to rank different forages and directly compare them. This is particularly helpful when comparing very different samples, like alfalfa and Bermuda grass. Now let's apply this to 3 different hay samples pulled from bales harvested in the 2019 growing season. It's obvious from this picture that not all hay looks the same, but can you accurately determine which hay is the best just by looking at them? Hay number 1 is from an irrigated, well-fertilized Tifton 85 hayfield. This sample has 61% TDN, 15% crude protein, and a 140 RFQ. Hay number 2 is from a dry land, lightly fertilized Tifton 44 hayfield. This sample tested at 49% TDN, 10% crude protein, and it had an 89 RFQ. Hay number 3 is a mixed Bermuda grass field that's not actively managed as a hayfield. This sample tested at 43% TDN, 7% crude protein, and had a 64 RFQ. Let's take this a step further and look at how these 3 hays could meet the requirements of a 1,200-pound beef cow in early lactation. This cow would require 58% TDN and 10% crude protein in her daily diet. Considering her body weight, this cow requires 17.6 pounds of TDN and 3 pounds of crude protein every day just to meet her minimum nutritional requirements. We can divide the amount of the nutrient required by the percentage in the hay to know how much we would need to feed to meet her minimum requirements. Energy is generally the most limiting nutrient, but not always. So let's take a look at this example. Based on the forage test, this cow would need to eat 29 pounds of the first hay to meet her energy requirements, while her protein needs were met at only 19 pounds of consumed hay. The same cow would need to eat 35 pounds of the second hay to meet her energy needs, again exceeding her baseline protein requirement that was met at 31 pounds of hay. Hay number 3 is a different story though. Here, protein is actually more limiting than energy, so she needs to consume 43 pounds of hay to meet the protein requirement, while the energy requirement was met at 41 pounds. But let's look at these in a more practical sense. This cow can only consume 30 pounds of dry matter each day. And so if we assume that hay is about 85% dry matter, then she can only physically hold 35 pounds of hay every day that we're not supplementing with any fresh pasture or grains. So let's look back at those pounds of each hay required to meet her minimum needs. Hay number 1 exceeds the minimal nutritional requirements of that 1,200-pound beef cow in early lactation, and she should metabolically feel full and stop eating before she consumed that maximum 35 pounds that she could eat in a day. Hay number 2 exactly meets her daily nutrient requirements, whereas the cow cannot physically hold enough of that third hay to meet her nutrient requirements on the hay alone. To illustrate this point, let's look at these samples from a different view. The piles of hay that you see here actually represent the pounds of each one required to meet the most limiting nutrient. You can see how much less hay is required for that first sample compared to the second and especially the third sample on the end. This is an excellent way to picture the differences in hay quality and quantity. Generally speaking, as hay becomes more mature, the yield will increase, but the quality begins to decrease. The first sample was cut around 30 days, where we were able to optimize hay quality and yield. The second sample was not cut until 42 days, and so while it may have increased yield, the quality was declining. The third sample was at least 60 days old when it was harvested, and so even though yield may have been very high on this particular field, the quality is far too low to meet the needs of this lactating animal. If you need help testing your hay or forage, contact your local county extension agent about collecting and submitting a sample today.